Hi everyone, I'm Heather and I'm an OpenSciEd teacher and facilitator, and I'm excited to provide you with an overview of Lesson 3 of the weather unit. This lesson is exciting for students because just in the previous lesson we said we wanted to see some data to prove that the air is either cooler or warmer higher up in the clouds where they're making the hail. So guess what? Today we get to look at some hail data from weather balloons to help us support or refute those student claims about temperatures high above the ground. So let's get started. How did we get here? During the last lesson, we figured out that hail is made of layered ice and can vary in size and shape and clearness. Most hail events are in the central US and happening on days that have temperatures between 50 and 90 degrees, which is well above the freezing point of water. So how is this ice falling from the sky? High humidity on these days between 36 and 97%, usually happening later in the day and in the warmer months. And they also tend to really only affect a small square mile area of about 20 to 60 square miles. In this lesson, we're still wondering, how does the air temperature at the ground level compare to temperatures higher up in the sky? In our lesson at a glance, we have a day and a half lesson, very minimal prep on your end, only about 10 minutes to make some copies of our data that we're going to be analyzing and annotating. And just one video that you'll need to be able to show about how weather balloons collect their data, how they're launched. It's pretty interesting, but it's embedded into your slides. Day one, just looking at our snapshot here, it's scheduled to be a half day, but I would loop part 1, 2, and 3 together so that it's one solid learning loop. In this section, we figure out that there's a very big difference in air temperature at the surface compared to higher altitudes, even in the summer months. And it's coldest up there in the winter, but even in the summer, we have a huge difference in temperature from down here to way up in the clouds, like 40,000 feet, where some of these pieces of hail are coming from. So it's pretty interesting to look at. On day 2, we have one big sense-making loop again that centers around figuring out particle movement with all this. So we're looking at when the temperature of air increases, we're now noticing that the particles that make up the air are also moving at higher speeds. And when air temperature decreases, the energy of air particles decreases too. So that's something that we figured out by that point. Altogether, we figure out that regardless of the season, the temperature of air is always decreasing as you move away from Earth's surface and higher into the atmosphere. The air temperature at very high altitudes, like 40,000 feet, is coldest in the winter. And when the temperature of air increases, the speed of molecules that make up air also increases. And when the air temperature decreases, so does the speed of the particles. Some key moments in this lesson. When we get to part 3, remind students to use the I-squared data annotation strategy that we used in lesson 2. The more they use it, the more comfortable they get and the more confident they get with annotating their data. Students are going to be annotating their air temperature data for these 4 different locations. They're data samples that are taken from the same date once per season and 6 different altitudes at that location. And each location is also at a different elevation above sea level. So that's kind of important to think about too. But again, the I-square method, really helpful here. For part 4, we're conducting a discussion, but I suggest that you make sure that you plan for the discussion using the suggested prompts and the key idea callouts that are in the teacher guide. The suggested prompts, and if you look closely, you'll see that the key science ideas are mentioned in the summary on page 1 of the teacher guide, as well as listed on part 4 of the lesson guide. So I kind of tried to point out there where you might see some of those call outs for both the questions, the suggested prompts, and the key ideas that you're trying to get them to explain and model. For part 6 and 7, our progress tracker and navigation. After we're building the understanding discussion, all the key science ideas are fresh in their minds, and perhaps even on a chart paper or somewhere visible, we can use this to help summarize what we figured out based on analyzing all that weather balloon data. For navigation, ask students to think about how we can use maybe some of these light sensors that help us investigate why the temperature differences occur, because we're still kind of stuck on well, how does it change so much as we go up higher? So thinking about tomorrow's lesson, and I know where we need to go. I know that we're wanting to use these light sensors. I just kind of strategically plant them up here and say, hey, I have these really cool sensors. How could we use these to maybe investigate why things are hotter down here versus up here. So give them an idea to like think about how could we plan an investigation. So where do we go from here? We will next lesson plan an investigation to determine why the air closer to the ground is warmer than the air further from the surface. We want to know why. We see that it is, but why? We will analyze temperature data and sunlight data to think about how incoming light and reflected light might be affecting the ground and the air near the surface. How are they interacting? And material tips and tricks for this lesson. Again, like I mentioned earlier, use the discussion planning tool to help guide you in the planning of the discussion in part 4 for the lesson. The planning tool can be found by clicking on the professional learning tab in the OpenSciEd page. Click on demand teacher support library. And then there is a bar that says discussion planning tool. And then click the view planning tool button to make a copy for your own use. This planning tool, it's a very quick fill out, but it's really helpful to make sure that you're asking the right kinds of questions to get kids to what you want them to get to. So use it anytime you have a heavy lift portion of the lesson. The progress trackers and the navigation in part 6 and 7 as a way to get students to think about what they need to figure out next, like use that progress tracker as that helpful navigation. How does the air down at the surface become warm, but the air higher up doesn't? That's what we're really wanting to like figure out. Like we know that it is, but how can we figure out next why? And again, planting that light sensor might be a way to help move them towards, like, we want to do some more investigating. So just having the materials out and visible can sometimes be enough to get students thinking about how we can use them to plan our next investigation. Hold up one of your light sensors during the navigation portion and get students to think about how they might want to use that to collect data tomorrow. Where could we measure light with this device? And how could that better help us understand how there's a temperature difference between the surface versus even just a little bit higher up off the ground? How could we test it out? And they come up with some pretty good ideas. You'd be surprised. So although we encountered some words, the word humidity in lesson 2, after this lesson, we have now seen it and in context, and we can start defining it and using the word moving forward. We also earned the words altitude and atmosphere as some terms that are very much applied in this lesson, and we want to make sure that we use those words moving forward in this lesson and in this unit in future lessons. The word temperature is important here, and it's carried over not only from previous lessons, but from the thermal energy unit. We want to continue to reinforce that temperature is a measure for particle motion and energy in the matter. In this case, the particles that we're measuring are the air at different altitudes. And as always, for poster management, I like to leave my driving question board and investigation ideas up to see at all times to help with that navigation. Other chart papers you might think about, like hiding those and just pulling them out as you need them, so you can focus on those as needed. Like the I-squared method, I usually have a chart paper for that. And on days that we're using the I-squared method, I pull that chart paper out as an anchor chart and use that to kind of help remind us of what we're looking for. Again, there's some really creative ideas on the Facebook groups as well for managing all of the chart papers and posters. I also mentioned on here maybe keeping a summary table by this point. We've kind of gathered a few key ideas, but by this point, maybe putting them up on a summary table that you can kind of keep track of all those key ideas moving forward. And it's visible at all times. My students really like this lesson because they're feeling more confident about their abilities to annotate and analyze data independently. And it was data that they really wanted to see and they needed to see in order to like prove their claim or refute it. We also know that we're making progress on our questions and we have more investigating to do in lesson 4 with the light sensor. So we're excited to come to that tomorrow. I hope this video is helping you feel a little bit more prepared to try this lesson with your students. And I wish you the best of luck out there. Thanks for watching.